Hello everyone, I am Rayala Gunadeep. I am from Jawaharlal Nehru Technological University, Hyderabad. I am studying in BTech third year, Electronics and Communication Engineering. Today I am going to share my internship experience which I have completed in Emertxe Information Technologies and the project which I have done during the internship course, that is washing machine simulation. So let us go ahead. What I have learned during my internship. I have learned about the embedded C programming, microcontroller fundamentals, the PIC16F877A specifics. This is the microcontroller which we will be using in this project. And the CLCD interfacing, PIC simulation tool, and the development environment and the tools. So for this, we are using MPLAB IDE and XC8 compiler. So what is embedded C programming? Embedded C is a set of language extensions for the C programming language designed to program microcontroller based systems. It enables you to write logic that interacts directly with hardware like sensors, actuators, and displays. The important embedded specific concepts are like firmware, middleware, and drivers. The firmware is nothing but the core software that is running in on the microcontrollers. It is written in embedded C. It performs device-specific operations. Example, washing machine control code is firmware that runs on the microcontroller. And middleware, software layer that sits between hardware and the application logic. It is called as middleware. Drivers are the firmware modules that handle specific peripherals. Example, LCD driver, keypad driver, buzzer driver, etc. Basics of C used in embedded systems. So, in this, we have learned about the data types, control structures, functions, and pointers. So for data types, we know that int, float, character, unsigned, long, etc. These are used for defining the variables. Control structures. We have some statements and loops for controlling the flow of execution. The statements are like if and switch statements, and loops are while and for, which will control the flow of execution in firmware logic. Functions are used to encapsulate repeatable tasks. Pointers are used for memory access, hardware register manipulation, and passing by reference. Embedded C is a hardware-focused C programming used to control microcontrollers. It combines core C concepts with hardware interaction like register access, timers, ISRs, and peripheral drivers. It provides the foundation to build efficient, real-time, and reliable embedded systems like your washing machine simulator. So let us know what is a microcontroller. A microcontroller is a compact integrated circuit designed to execute specific control tasks. It combines CPU, memory like RAM, ROM, EEPROM, IO ports for interfacing sensors, switches, and displays, timers, counters, analog to digital converters, communication modules like UART, I2C, and SPI. Uh, we know that microprocessor and microcontroller are there. So what is the difference between microcontroller and processor? So microcontroller is used in embedded control systems. Microprocessor is used in general purpose computing. The components are CPU, RAM, ROM, IO, and timers. All were integrated in a single chip in the microcontroller. But in microprocessor, only CPU is there. The other rest like RAM, ROM, input output timers, ADCs, these all to be given externally. The cost is low for microcontroller, but for microprocessor, cost and power both are high. Examples of microcontroller are PIC16F877A, which we will be using in this project, and ATmega 328. This controller is used in Arduino STM32. Microprocessor examples are like Intel i7, AMD Ryzen, etc. Let us briefly know about PIC16F877A microcontroller. The PIC16F877A is an 8-bit microcontroller developed by the Microchip technology and is used widely in embedded systems due to its rich feature set and ease of use. It operates at a frequency of up to 20 MHz, which is a clock speed we have used in our project. The microcontroller is used for applications like automation and control systems, making it a perfect fit for our washing machine simulation. This device has a total of 5 I/O ports, port A to port E, which can be configured for various digital input and output tasks. In our project, port P is used to read digital switches, port D and port E are connected to the CLCD display, and port C controls the motor and buzzer. It includes 14 kilobytes of flash memory, which stores the firmware, and 368 bytes of RAM, which is used during program execution. It also contains 256 bytes of EEPROM, which can be used to store user data that must be retained even after power off, although we haven't used that in this simulation. One of the key features of this microcontroller is its support for hardware timers. It has three timers, timer 0, timer 1, and timer 2. And this project, we have used timer 2 to generate time delays and countdowns for washing cycles. Additionally, interrupts are a vital part of this microcontroller, enabling it to the respond instantly to import events like checking the door status and updating remaining time without halting other operations. So here we can see that there are 40 pins, 20 this side and 20 this side. So next coming to the project. Our project is washing machine simulation. The primary object of this project is to simulate the functioning of a real-life washing machine using a PIC16F877A microcontroller in a virtual environment with PICSimLab. The system is designed to replicate essential washing machine operations such as program selection, water level control, cycle timing, door safety detection, and completion alerts, all without using actual hardware. This project involves designing and implementing a software-based washing machine controller using embedded C. The microcontroller controls the operation through switch inputs, displays information on a CLCD, and simulates outputs like a fan and buzzer. The user can power on the machine, navigate through multiple washing programs, select a water level, and start the washing process. The program then runs through the selected washing cycle, showing the function in progress. Like we have different functions like wash, rinse, or spin, and the time remaining. A buzzer alert is given if the door is opened mid-cycle, ensuring safety. After completing all operations, a message is displayed to the user indicating that the program is finished and clothes can be removed. The simulation is done entirely using PICSimLab, where each hardware element, such as switches, LCD, buzzer, and motor, is virtually represented and controlled via C code running on the PIC16F877A microcontroller. This project helps in understanding how embedded systems are used in automated appliances, how firmware interacts with hardware, and how real-time systems are designed and tested without requiring physical components. So we all know what a washing machine is. Generally, it is available in everyone's home nowadays. So it is an intelligent household appliance designed to automatically wash clothes by performing a sequence of operations. In this project, we simulate a washing machine using PIC16F877A microcontroller and PICSimLab, a virtual lab environment. Purpose of simulating the washing machine. We can understand the real-world appliance behavior using microcontroller logic, learn the embedded system design with inputs, switches. The inputs are given as switches and outputs are CLCD, motor and buzzer, and decision-making logic. We can gain the experience in project development, debugging, and simulation without needing actual hardware. So the key features simulated in this project are, so to power on the screen, we need to press switch 5 and washing program menu. For there are different washing options I have given in this project. So to select one, we need to press switch 4 and water level selection also it will select the water level. For this also we will be using switch 4 only. If we want to select, we need to give long press and start or stop option. Switch 5 starts the selected operation. Switch 6 can stop it anytime. Function display. It shows the current operation, wash, rinse, spin and time remaining. Door status detection. Switch 1 is used to indicate whether the door is opened or closed. This is the interrupt we are giving. And completion message. It displays the program completed. Remove clothes at the end of the cycle. This is the architecture of PIC16F877A microcontroller. We can see that GPIO pins were there, and this is I2, IC2, RTC real-time clock, and double EEPROM. And these are some sensors we are having. And RS232, this is a communication protocol, external communication. And LEDs, buzzer, digital keypad, SSDs, and matrix keypad. All were integrated in the microcontroller. Let us see the peripherals that are used in this project. So first one is CLCD, that is character liquid crystal display. So in PicSimLab, 16 into 2 and 16 into 4 CLCDs are available. We are using 16 into 4 display. Here we can see 1, 2, 3, 4 columns were there and 4 rows were there and 16 columns were there. It displays ASCII characters only using some special symbols. Communication modes are 4-bit and 8-bit. It is used to show program name, time and status. Tactile switch. A tactile switch operates by touch, gives physical feedback. So we can't touch, we need to give click through mouse and use it to select programs, water level and start or stop in our project. Connected using pull up and pull down resistors. Needs debounce handling due to bouncing effect when pressed. So there is bouncing effect in the switches that we need to overcome. Matrix keypad, which we can say MKP. MKP stands for matrix keypad. It's a group of switches arranged in rows and columns. Here we can see there are 4 cross 4 matrix keypad. It saves IO pins, useful when many buttons are required. Commonly used in calculators, phones, and digital lockers. ISR, interrupt service routine. It is a function that runs when an interrupt occurs, clears the interrupt flag and handles the event. Must end with return file to return the main program. Ensures fast and real-time response. Example, door open. Next, the timers. Timers are used to measure time, creates delay or trigger tasks. Controlled by internal clock signals. Can count up or down with configurable resolution, that is 8-bit or 16-bit. In this project, timer 2 is used for cycle timing. Buzzer. A buzzer is an audio output device used for alerts and warnings. In this project, it is used to indicate door open and program completion. So this is connected to RC1 pin of microcontroller, like buzzer on or buzzer off. We have two application in this project with buzzer. I'll show in the project demo. And coming to the fan, the fan simulates the washing drum motor in this project. It runs during wash, rinse or spin operations. It is controlled with RC2 pin and driven as a digital output. It is controlled in code using fan equal to on or fan equal to off. Whenever the washing washing program is starting, it will start to rotate. So now let us see the project demonstration. This first I will be showing you the code which I have written. So I have created washing machine project, and in this header files and source files were there. So header files are like clcd.h and digital keypad.h, main.h. So we need to create some macros in this header files, and this is timers.h, washing machine.h, and coming to the source file, this is clcd.c, digital keypad.c. So here we are giving the long pressed mm, isr.c, and this is main.c. This is the main program we have written for our project. And timers.c, we are using timer 2, and washing machine.c. This is the washing machine.c program. Here we are using switch case, switch statement, because to give how much time to be take taken for each washing machine program options. For that we are using switch statement. So this is the program. Now let us go to PixSimLab and see the demonstration. So at the beginning I have told that we are using 20 megahertz frequency. So 20 megahertz has to be selected. And first we need to see press key 5 to power on washing machine. Now this is key 5. So we will be getting powering on washing machine screen, and it will direct to the washing program screen. So these are our washing program options. To select or switch from one to another washing program, we need to select press on switch 4. So we are having about 11 washing programs like daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse and dry, dry only, wash only, aqua store. So I will be selecting the daily. To select, we need to give long press. Now, water level screen has come. So in water level, there are 5 options like auto, low, medium, high, and maximum. So let us select auto. Okay, let us see medium. Now press switch 5 to start and press 6 to stop. So it is not started yet. So we'll press switch 5. So it will give this screen. After 2 seconds, the function will be starting. So it is showing wash and timer is running, and the what we say fan is also running. So if we want to pause, we need to press switch 6. So timer has stopped and fan is also stopped to rotate, and function is in washing mode, it is there. So again, to continue, we need to press switch 5. Again, timer has been starting running and fan is also rotating. If suddenly one interrupt has occurred, that is door is open, so we press switch, so we need to press switch 1. After removing, again it will be starting. So again the function has changed from wash to rinse. Next, after some time it will change to spin. After com after completing, we have seen that remove program done, remove the clothes. And after the buzzer has sounded. Now washing program screen is again displayed. Now again you can change from one washing program to another. If you want to select, you can press long press the switch 4. So this is the operating. Now this is the project demonstration conclusion. The washing machine simulation project using the PIC16F877A microcontroller provided valuable hands-on experience in designing and programming embedded systems. By simulating real-world appliance behavior in PixSimLab, we gained practical knowledge of hardware, interfacing, embedded C programming, and system logic design. We have successfully implemented key washing machine features such as program selection, water level control, timed operations, buzzer alerts, and door safety checks, all using digital inputs, outputs, and timers. Thank you.